Hello, everyone, and welcome to the first edition. We are the first of many of the Privacy Engineering Conference inside Apidays. All day, we'll be giving the floor to engineers, lawyers, CEO, or activists to help you understand what is privacy, why you should care about it, and how to implement it in your systems. So our goal here is to contribute in the raising of a new generation of privacy engineers and privacy architects to tackle this main challenge of the 21st century in the digital world. And what better way to start than to give the mic to Jan Oliver, who has accepted to open this first privacy engineering conference. Hi, Jan, how are you?
I'm good, thanks.
So, Jan, you are senior security researcher at Nokia Bell Labs. You're former privacy officer for Nokia Services, and you are the author of Privacy Engineering, a Data Flow and Ontological Approach, a book that you published in 2014. And I would say in its books, you were one of the first one to define the term privacy engineering. And today you've decided to talk about privacy engineering, the state of the art. So the goal is to understand why to achieve privacy in systems, how to do it, and how to level up the engineer culture on that subject. So everyone here, don't hesitate to ask questions and interact in the chat, because we'll have a little Q&A at the end of the talk with Jan. So Jan, I'll let you complete this little intro if you need to, and I drop the mic to you.
Great, thank you very much. Pleasure to be here. Okay, so yeah, I guess I was probably one of the first people to call themselves a privacy engineer. At the time, when I actually joined this, I came from Nokia Research and joined a team of 25 marketers and lawyers who were looking at privacy at the time. So I was the first technical person. And one of the big complaints they had at the time was that none of the engineers would speak to them. And that was a very, very interesting 5 years of actually trying to solve that problem. So what I'll talk about today is what we did during that time and some of the results that have come out of that afterwards. So in this case, I guess state of the art actually means not the current state of things, but actually how we got here, which is a very interesting story in its own right. Okay, so let's start off with a little bit of history. So in sunny Espoo, Finland, about late 2009, 2010, I started work as what was called then a privacy architect or a privacy engineer, actually working with the software developers who now had to comply with additional requirements. This was the European Data Protection Act, there was the Safe Harbor Act, and so on. And of course, we were selling products in the US, so we had HIPAA, COPPA, and all the rest of the US legislation, which is still very much scattered. At this time, the GDPR was still 5 years away, and it was still just starting to be talked about how we should build the GDPR. So in order to start this off, I brought in, we took all the standard agile development techniques, so we developed lots of epics and use cases for privacy. We looked at how we integrated with the software development process. We did a lot of work on translating legal documents. So when I joined, I was handed a 150-page Word document, which was just full of legalese. It had no resemblance to anything any software engineer or human would understand, actually. And this was part of the complaint between let's say, the legal side and the engineering side. We gave a lot of training to the software engineers. We sat them down and explained what these things mean. And of course, explaining legal terms to software engineers isn't always the easiest thing to do, and especially when there's very, very little context. We defined what it meant to be compliant, and this is a horrible term which came back to haunt us many, many times. We talked about privacy by design, so Anne Kevorkian's list of 7 items that you need to follow in order to be privacy compliant. It's a very nice starting list. It's very much like the Agile Manifesto, but it gives you nothing about how to do this or what to do this and so on. It's just a nice set of principles, if you like. We were even quite agile, so we could jump anywhere into the software engineering process, although as I think people have experienced here, that agile really just means a reworking of the waterfall-based software processing methods and so on. And also, to really understand all the products that we were developing in Nokia services at the time, we sat on pretty much every single software architecture and design review. So it was hundreds of hours of meetings. That was fun. Now, the two pictures on the side, I have a background in safety critical systems, and I basically studied how industries like, especially aviation, dealt with safety issues and how they addressed things like what happens when systems wrong, or how do they check systems, how do you make sure everything is right. The crashed aircraft at the top, it comes from, I believe, the late 30s, early 40s. And it was the first air crash which was properly investigated. And now, of course, we have extremely high level of safety in aviation, and checklists are a fantastic tool. They're not to-do lists or tick boxes. They have their own semantics, which we need to understand. And I'll come back to that later, because that was probably one of the biggest things we got out of this. So we developed all this, and it failed badly. Without a doubt, okay, we had some successes, but we failed completely on getting privacy requirements as a first-class software engineering concept that people had to deal with. So how do we deal with that? It's quite easy. We went back and improved everything that we're doing. So we wrote even more epics, more checklists, got deeper into the software engineering process. We attended thousands of hours of meetings now over the next year to really discover what went wrong. We were very, very introspective about this. Why were the engineers not understanding privacy requirements? And after we did all this, this was basically a complete failure again. So again, we failed to get privacy into the software engineering ethos, as, for example, security and resiliency and performance were already there. So this, after many discussions, this actually led us to the fact that the real work is not getting privacy into the software engineering process, but really bridging the gap between the privacy legal and the engineering side. And that's a really, really difficult problem. Nobody, as far as I can see, had tackled that before. So in 2011, we sat down and thought an awful lot about this. So it seems like the privacy legal forgot that the job of the company is to build products and sell them to customers. There was so much adherence to process. We were doing the privacy reviews right at the end. We were trying to take away responsibility from the software engineers and so on. Privacy design was just a bunch of buzzwords. But two of the most interesting things coming out of this was that privacy legal was talking about personal data and PII, and engineers are talking in terms of data models and the structures that exist there. The second thing was that every time you talked to a privacy lawyer, they would say no. Can I collect location data? No, it's too risky. Can I collect X? No. Can I collect somebody's name? No. And the answer was no every time. So in the end, the engineers just didn't talk to the lawyers, and that was just the start of it. So it was around this time we had a little bit of serendipity. I was handed a copy of Atul Gawande's book, The Checklist Manifesto. And Atul Gawande was actually a surgeon who was in charge of developing the surgical safety checklist. I strongly recommend you read this book. So it will really turn the way how you think about processes. And after reading this and looking at some other material that's done in the medical area, we realized that, first of all, there are a lot of similarities between medicine and software engineering. We were both very, very agile, and unlike aviation's rigid procedures, things go very, very wrong very quickly in medicine, and we had the same things happening in software engineering. But most importantly was that medicine had this idea of separating sterile and non-sterile areas. And then we thought, well, isn't information kind of like an infected hazardous substance? And we have to control its movement. And that led us straight into how we model the flow of information, which sounds quite obvious, but I mean, up until that point, there was really only one method that really tackled that, and that was Microsoft's Stride method, and that was so specific to security that nobody had ever thought about really applying this in this area. So we started developing data flow methods on just to understand how information flowing around the system. And this was quite interesting from my perspective because I'd worked with modeling languages like UML from the very beginning, even before it was public. So I sat down and then used my engineering brain rather than my privacy lawyer brain. I thought, actually, what happens if we turn this into an engineering discipline and used all these really cool ideas from safety critical systems? So at this point, I'll say I invented privacy engineering. Probably not the first with this idea, but there's a lot of people around the same time that were thinking about this. But hey, why not? Let's talk oneself up anyway. So we invented privacy engineering in a form inside Nokia around that time and started to develop that. The first thing that was very interesting for us was how requirements were being expressed, because from the legal perspective, they were very, very interested about the privacy policies that had to be displayed to the user, and that was the basis for all requirements. Now, if you've ever read a privacy policy, it's the piece of text you're supposed to read before you press accept. You notice it has nothing or very, very little to do with actual engineering requirements and what's going on at that level. If you're lucky, it does talk about maybe specific classes of data, and it might talk about some kinds of actions or aspects of that data set. We would like to store your data in the cloud, or we will use your personal data for marketing and things like this. And what we realized after reading quite a lot of these is that we could build up a set of requirements based upon these different classes of information that they were talking about. And we just listed all the different types of information that our privacy policies were talking about, whether it was public data, confidential, financial, location data, whether we could use your photos, your identities, and so on. We had lots of discussions about exactly what identities were at the time, because you had application IDs, session IDs, user IDs, government issued IDs, IDs come in all sorts of different forms depending upon how long lived they are and so on. Then we looked at a lot of the aspects of this. So this was a completely orthogonal dimension. We talk about things like how we were storing data, where it was being stored, what the data was being used for, and so on. And so we came up with a whole bunch of requirements aspects. And then we sat down and looked at the detail of these and said quite simply that, okay, this is all policy stuff. This is our privacy policy, and that's the level which these are written. So we could do a deconstruction and say, look, if we're talking about how we store your identifiers, our policy on that, which gets written into the privacy policy, is we will store it and use it for these purposes. And then it was reasonably, I wouldn't say it was very easy, but it was reasonably easy to then say, well, okay, what happens if we start making these requirements much more detailed as we move through architecture, design, code? What would these requirements mean to these groups of people? Now, the diagram that we end up doing, this little space of these three elements, they were effectively, with the amount of aspects, the details, and the classification elements, there were 72,000 slots in this that we could fit in requirements. From our privacy policy, we filled in about 10 of these slots out of 72,000. Now, you don't need to fill in all 72,000, but you do need a way to say, look, if there's no requirement, say, for location, an architectural requirement for location data regarding its retention, then at least you know where to find it and you know what's missing. In fact, after about a year of doing this exercise and working with the architects and how we might engineer these and lots of discussion, we only filled in about 100 requirements, and some of these were quite esoteric as well. Interestingly, some of them came from the security side. You must use SHA-256 for hashing and things like this, and so on. But we generated about 100, maybe about 120 requirements by the end of this. But we had a mechanism to say, look, if I can't find a requirement, then this is how I go and search for the next level up. So if I can't find an architectural requirement, then I'll go and search my policy requirements and then be able to work down from there and have discussions about that. So this now at least gave us a way to start talking with the engineers. So when they came to you and said, okay, how should I handle this kind of identifier, or how, what should I set the destruction policy on this database? We had a concrete requirement that we could then match against the policy and do also very nice, clever, formal refinement stuff on this. We did start some work on actually making formal methods out of this, but that was maybe a step too far, but it can be done. Now, what then came out of this was, okay, now we know how to do requirements. Let's actually look at where the information was flowing. So we took this idea that information is a hazardous substance, and we need to control its flow. So we developed a very, very simple modeling language, a very simple data flow language, where we talk about, okay, there is a data subject, and there are environments where data comes from. It flows into processing elements, which might be very high-level things such as the application you development, and we could talk about where other information has come from, say from the operating system. We could put boundaries around this to say, okay, this stuff is on the device, this stuff is in the cloud, and then we could show where the information is flowing. So there's a very, very simple, and actually below is the generic template for a lot of the models we built. What we were able to do with this is then have a proper conversation about what information was flowing between things. So it maybe didn't matter what was being inside the device, but when you notice these data flows were crossing boundaries, say from the device to, in this case, the social media provider, then we could have a proper conversation about what information was allowed to flow over there and actually justify our decisions. And in this case, from this very simple model here, this focused people on saying, look, if you're going to send any information to a third-party service, then there's going to be a known audience, an unknown audience. That third party is going to store the data, and it's quite likely going to push it out to some other unknown people. So we've got an arrow here going from social media service out to others. And this dashed circle basically meant that this is what information could be hacked, or this is what an unknown authority could be doing here. So this started to focus people, and it gave them a language to talk about. And this was quite a revelation for us, because it meant for the first time we could show a very simple picture to the lawyers, or the legal side of privacy, and to the engineering side, and they could both have a meaningful discussion about this. Now think about that for a moment, a meaningful discussion between a lawyer and an engineer. Okay, so what happened next? The next thing that we noticed was that people were talking about personal data. Privacy people love talking about personal data and sensitive data and personally identifiable information, which is now a deprecated term. The first thing that we did with this term was to ban its use. We made sure that nobody was allowed to use the term personal data. And the reason being is because personal data is very context dependent. And the engineers themselves, there is no programming type called personal data. You have a database and it's got lots of individual fields in there. And a lot of the terms like identifier, personal data, location are actually derived from the contents of that and the context in which you're working. So that was a very interesting point. But it also then meant that we needed some way of talking about what kind of data we're dealing with at a high enough level that you could reason about whether it was personal data, and at a low enough level that it actually made sense to, say, the guys developing the database systems and the back-end systems. So this is a really good tip for you. ban the term personal data and force people to talk about what the data is. So this now led me down another route, which was my love of semantics and description logics and being sort of a mathematician in my spare time. So we started developing ontologies, standardized sets of terminology with some semantics about what we were dealing with. And so, I mean, we talk about the requirements aspects. What should the requirements of privacy relate to? And this was one of the first ones we developed up. So how were we allowed to collect data? How should we store data? And there were different categories of storing. The requirements, privacy requirements on local device storage versus, say, cloud storage. How should data be transported? I mean, it's all very good to say encrypted in transport, but what are the specific requirements on that? You know, what from a policy view, we have encrypted transport, but from an actual code and design point of view, we need to decide whether we encrypt the data or do we just rely on TLS, transport layer security, and so on, and then to what level, what encryption algorithms should be used, what hashing algorithms, and so on. Handling of data, who's allowed to handle the data internally and externally. So we put limits on what could be done there. Access control to data, longevity of data, what kind of audit trails do we require, third-party access, geographic aspects of the data, and so on. Where is the data allowed to flow to? Is it allowed to flow to the US from the EU and vice versa? So this now starts to tie down the requirements into particular categories. The other thing we did was, came out of the work because we banned this term personal data, was to talk about what classes of data are we really dealing with. Are we talking, let's start with, say, financial data. This means any data that's related to the amounts of money, credit card details, anything like that is called financial data. Health data. Health data is interesting. So if health data can either be related with sort of exercise and so on, say the data that's coming off a Fitbit or some exercise tracker, versus, say, medical data, which is data that's been generated by a doctor for a specific reason. And they have very, very different characteristics, especially in the US. Identifiers were very interesting because what actually constitutes an identifier? There are lots of different kinds of identifiers, personal identifiers. I mean, that could be your social security number, or it could be a temporary number. In some cases, it could even be your IP address. So we need to decide, when we were using certain kinds of data as identifiers versus when we were not, and what kind of identifier, and the longevity of that identifier, etc. Temporal data refers to time stamping of things. Location data, fairly obvious, but even things like IP addresses can be considered location data. And we had one very interesting incident when Nokia had a mapping company when we bought Navtech and then later became Share Maps. At one point, our privacy policy did not refer to location data at all and how we handled that. And that was a minor oversight, but it was not obvious until you actually formalize the privacy policy in these terms. So it might seem strange that the mapping company forgets about location data, but that can happen. So we had all these categories. Now, in the book I wrote, and this is also in other presentations on this subject you get from my SlideShare site, there are much deeper ontologies underneath here, and they're actually very domain specific, but they do exist. The other thing we noticed is any data set that contains identifiers of any sort, location data and temporal data, i.e. timestamps, is usually a very, very risky data set. And the inclusion of two out of those three normally implies some personal data. That was a nice rule of thumb that we came up with. Other aspects. So privacy is not just about the information itself, but actually what you're putting what use you're putting that information to. And we came up with a whole bunch of different categories for these. The interesting things here was the difference between service provisioning and system provisioning. So if you say have a REST service, a nice REST API, you're going to be collecting logs from that. That it will be necessary for you to collect IP addresses. That's information that gets gathered because you need to run the system. Which might be very different from the information you're gathering to actually go run the service. So that was a very interesting distinction there, and we actually, that came up because of the fact we actually had one privacy lawyer who once asked us, could we get rid of IP addresses? And we said, yeah, we can remove them from the logs. He said, no, from the internet completely. So we wanted, it was a nice opportunity to redesign the entire internet without addressing, but completely impractical. But we did have questions like this coming up. So this allowed us to split up, say the log files gathered by the system versus, say, the data that's being used for the service that the system is providing. So we had a whole bunch of these categories. Okay, so here's another sort of breakdown of this. So as I said earlier, I mean, we can go from these very high-level generic categories into much deeper, more specific categories of information if we need to. So, for example, as I said about identifiers, we identified that there were session identifiers, application identifiers, personal identifiers. Some personal identifiers, like social security number, have government restrictions on them, passport numbers and so on. And then there were the identifiers for objects, such as machine addresses, which could be IP addresses, physical object addresses, URIs, and so on. And similarly, we had this aspect called characteristics, which talked about more opaque data like contacts, demographics, and so on. Now, once you have this, you can start actually adding this information to models. So we can say, look, if we have, say, an application that takes pictures and shares them to social media service, how is it communicating with other parts of that system? What data is flowing over there? So out of this application, we had 2 data flows. One of them contained identity, content, location, temporal data, i.e. the picture and the user information. And then there was another flow coming out of this that had also identity, location, temporal data, but also some kind of event data, whatever that means in this context. And there were 2 flows within a device, and then we could actually map throughout the system where this information was actually going. We can actually do some very nice tricks on this, and I'll demonstrate that now in the coming slides. So what we started to do was change the process by which we build things. So instead of starting with how do we present the privacy policy to the user and what kind of consent, do we have an accept screen and all this stuff before you get to the app, we changed the process for the engineers and the lawyers to start with, okay, let's build a model of the system and what information do we think we're gathering. And actually, what we have on the page here is a very simple model which talks about, okay, there's a user who interacts with a camera application. You can take selfies and whatever one you want with it and share it out to a social media service. And actually, this model was maybe one of the turning points for our relationship between the engineers and the lawyers, because this was the first model we produced where the lawyer said, oh, so that's where the data is going, and this is what you mean by privacy. And it really changed the whole culture around that. So this was the first time we had proper communication and could actually reason between lawyers and engineers about exactly what was going on in the system, and how things were going out to advertisers, social media platforms, third-party backups, and actually how the marketing was interacting back. Now, this model was also very interesting because we were asked by the lawyers, can you give us more information? Can you go to a level deeper? Now, bear in mind, these models also were annotated with information, as we had in the previous model, about what information was being carried with this. But we also annotated that information about what usages they were being applied. So we started a very nice refinement process, and we ended up with this model. Of course, it's missing the annotations on the data flows. But these were all the data flows that we discovered for a simple application that took pictures and shared them to social media. The box on the left-hand side in the middle is what's actually happening on the device. We identified 3 areas in storage where things were going. We had a product improvement library which had its own storage, and of course we were gathering data from the OS services, location, and so on. But from there were 4 points to which that information was flowing. One was out to a third-party backup provider, and of course, from there it might be going out to a possible 3-letter agency. We don't know. So that was an area of risk that we identified. Then we had the information that was going out to social media providers, with the proviso that this could also be going out to the public as well by default. And this also, this data flow here was actually modified. So even though companies like Facebook say we strip certain EXIF information out of pictures, we would actually do that ourselves on the device to make sure the minimum amount of information was going out to whatever social media provider. We had advertisers coming into this. We had an advertising ID as well, which is being provided by a third-party service on how that data was being used. And then we had our back-end services, which is the stuff on the right-hand side. And that was quite an interesting mess, but we could trace through how information got through to marketing and where they gather things from and what they would use it for. What we also discovered from this was that our segregation of internal users or partitioning of internal users was not sufficient. So the guy who ran the system also had all the passwords to the databases that actually ran the service. The other thing we discovered from this model was there were some very interesting loops. And if you follow the flows around the model, you actually see that you can get to our back-end systems via the social media provider and via the advertiser. So there was some interesting leaks of information coming through from them, which we then had to analyze and discuss exactly what was going on there. So this was the first model that we did this. And then we passed this off to we did further analysis on this. And one of the interesting things that comes out, I'll show you with this model here. So this was a quite nicely annotated one that we built. If you notice that on the later data flows, we have information type, we have various classifications. We also have notices about the usage. Now, it turns out that there were some very nice calculations that we could do. If you looked at the points where the data was going to be used, finally used by in this case, the product teams or marketing, if you trace usage back, then these all effectively add up. So what you end up generating at the end of the day by tracing all these flows back is the total set of all information collected and the total set of information and usages. And formally, this turns out to be an interesting tuple of information type by usage. And if you match all these tuples up, what you effectively now have is a formal description of a privacy policy. And for the system that we were building at the time, which was part of our mapping system, actually it was for taking pictures of road signs by users and so on. We took this formal description, and then from that we generated a privacy policy. We did it by hand, admittedly, but we generated a privacy policy from the model that we were that we built, and this was the first time we did that. The really interesting thing here was then we actually matched this against our real privacy policies generated by the lawyers earlier, and actually found a lot of holes in the system that would need to be patched up. And these are basically done by adding annexes to these for specific applications. But this was a very, very nice example of what you can achieve using the modeling. The other exercise that we did around this time, and I briefly mentioned this earlier, was to take our privacy policy and map that into these information type usage tuples. And there we also discovered that there were many holes. And as I said, as a mapping company at the time, we had no reference to location data, which that was a nice result. But I mean, actually, for the first time ever, from this, we were able to properly construct a privacy policy. We were properly able to justify the secondary usages and all the examples, such as we'll be allowed to collect data for product improvement, which is a very different aspect from the privacy policy and so on. So we could stack all these up together and really simplify them. Now, whether the lawyers wanted to simplify them is another question. But from our perspective, we now had a method of making very accurate privacy policies out to the user and then being able to demonstrate that the product was compliant with that. So for the engineering perspective, for the next release, when they added a feature, it was almost trivial for them to say, are we adding a new information type? Are we adding a new usage, etc.? And if they were, then it was a very short conversation with the legal side to say, okay, are we able to do this within the confines of the current policy, or do we need to do a quick privacy review? Now, this is jumping a little bit further ahead in time. So around 2016, we while we were applying this to some very interesting cases, there was this huge thing about differential privacy coming up, and whether just magically applying differential privacy would solve all your privacy problems. It doesn't, by the way. But we made a very simple data flow model of an interaction between Nokia and another telco company, and the data that was flowing between us. They were supplying us with some inferred location data, and we were asked to apply differential privacy for this. And this led to a very interesting research question of, could we properly measure privacy, or the degree of anonymization, in the sense that we could say whether this was anonymous enough or not. So I'm just being told there's a sharing bar appearing on my screen. So now imagine being able just to take a data set and apply a function to it, and from this you just get the result, this is privacy compliant or not. Is it sufficiently anonymous? Now what we did was we took data sets containing location timestamps and identifiers, and then we used some algorithms from machine learning, basically entropy calculation algorithms, mutual information algorithms, and then plotted out a value corresponding to the mutual information from those. And then we anonymized some of these at hand and so on. And then we then took some differential privacy algorithms with the epsilon and delta parameters, and then we basically generated thousands of data sets from here by applying differential privacy to the temporal and the location aspects. And we plotted the graph that you see on the left-hand side here. And this basically says that for decreasing values of epsilon and decreasing values of delta, the amount of mutual information, i.e. the amount of noise that we've added to the data set, decreases rapidly. So this was a nice result. Now what we could do then is basically say, look, everything in the blue section is sufficiently anonymized, and everything in the red section is not sufficiently anonymized. So this gives us a classification function. I should bear out, while these diagrams look quite nicely, each point in the diagram was a 20-dimensional structure. The knife, the mathematical knife that we used to cut the diagram in half, was itself a 19-dimensional structure, but the maths was really fun, but horribly complex. The other thing that we were able to do then was to say, look, okay, if we've got functions that, given certain parameters on operations, modify the data, then we could actually go and plot these functions and effectively the routes that they take through this data. So we could say on the right-hand side that our original data set, the point in the red section at the top, generates this amount of mutual information. If we apply a function, let's call it a function called A1, and then compose with A2, then it takes us to a data set with this amount of mutual information. So we could actually now start investigating how privacy preserving or private noise addition certain functions were over this. And there is a paper on this from a conference called Quatic. The other thing that we did was generate a lot of tools. Now, I mentioned the aviation checklists and the surgical safety checklist. We took these ideas and we generated a privacy review checklist, which allowed us to these were basically a checklist for us to make sure that we were doing the job correctly. Now, the interesting part about these checklists and the way they should be run is they're not tick boxes, but they are certain things that I should try and establish before moving to the next stage of the privacy review. So now the privacy reviews were a continual thing throughout the life cycle of the product. And using these checklists basically allowed us to check whether we had gathered the necessary information. If we missed an item on the checklist, it didn't matter. It was just a warning to us that we were missing some information that might be very relevant later. And so we were able then to much more focus our investigations on whether a product was compliant in some sense. So this is our first step into using checklists. And what was very interesting about this was that the development team started asking for these checklists. And then we generated a little more for those, so they could also prepare themselves and be in a good state. So it gave them a good trajectory for developing those systems. So this was a very, very useful tool. And if you want to be able to use checklists, I would recommend that you go and read Atul Gawande's book on this. Now, the other tool that we had was how we dealt with risk. Now we've got some notion of metrics, even very rough metrics, like saying one type of data is much more risky than another. We had areas of concern, which are our requirement aspects, and we had a model of the system. Once you have those three things, then you can start doing formal risk analysis, and we used FMEA for this, and which is even though it's a very crude tool, it actually focused us on a whole bunch of areas, such as from the model we could say what is the, if we're collecting fine-grained location information and so on, what is the risk of it being compromised according to our areas of concern, and then we use the metrics then to guide the figures that we placed into the FMEA. And from this, then we could prioritize which areas of the system were of concern in a very formal way. Now, what's very interesting for us is that we started doing this in 2012, 2013, and the GDPR, which came out 2014. We input quite a lot of this to the working parties that developed the GDPR, and this is why the GDPR is ostensibly a risk management exercise. It is not a compliance exercise. Which is very, very interesting. If people start telling you that you need to be compliant with the GDPR, they have not read the GDPR. I can guarantee you that. GDPR is a risk management exercise. It does not stop you collecting all sorts of bizarre, unethical, highly personal data, but you had better be ready for the risk that you are taking with this data. And this comes back to the last point. So this is a cartoon actually from the FAA, and this is how privacy risk analysis is taken. The most interesting thing that started to happen was the culture of privacy engineering changed from being a legal compliance exercise into a much more engineering risk assessment and risk mitigation exercise. And that has dramatic effects on how you approach the system. It then becomes very much easier to develop systems. You can say, right, I'm going to collect real-time location data from children along with their ethnicities. I mean, that's really a horrendous thing to do from a privacy perspective. Oh, and by the way, I'm going to put it on Amazon Cloud in, I don't know, China or India or the US or wherever. But it allowed you, using these techniques, to justify why you were doing this and the reasons that you were doing this. And then you would use that to drive your discussion then with the security teams, with the ethics teams, and so on. So privacy is no longer just this esoteric legal thing. It's now a risk management exercise for the engineers with very clear links to security, to ethics, to performance, and so on. So I'm coming up to 45 minutes on here. So as a very brief summary, if you want to do privacy engineering properly, it's not just about dealing with personal data, and it's not just about building models. You need to build models, but then you need to understand that those models are part of a larger risk analysis mechanism that you have. And once you have that risk analysis mechanism, then you can start making very interesting, justifiable decisions. And once you have those decisions about what kinds of data that you're going to build and so on, then you can start building your mitigation. Mitigation here means what security procedures do you put in? Do you stop collecting certain data? And so on. And then you can have very meaningful conversations with lots of other disciplines. One very interesting thing that came out of this is if anybody says we're going to collect data for some future purpose, that was immediately a big red flag, because that means you are over collecting data. It also gave us the ability to stop requirements creep. So people, oh, I need to add this requirement and this sound requirement. Let's collect this data and so on, or let's do this analysis. You could actually put a stop to this and say, look, this is the amount of risk we are taking for version 1 of the product, and then we'll start looking at these additional risks later. So you could actually push that back in the software engineering process. The other amazing thing that I would recommend you do is just to ban the term personal data. It's a good term for the legal side, but you should ban it from any discussion. So talk about what data and what usage that you're putting that data to, and then decide later whether it is potentially personal data. In fact, at the end of the day, pretty much everything is personal data. And one thing that the GDPR does not do is tell you not to collect personal data. It just tells you that if you believe your data is in any way linkable with the person, then just do a proper risk analysis on it. So any lawyer that says, no, you can't do that, has misunderstood the GDPR. And finally, you need to move your culture from a compliance-based culture, one that keeps on saying no effectively, to one that deals with risk assessment. Right, and then just to quickly finalize, I just want to come back to a bit of history to tie some of this. I published a book called Privacy Engineering, which details a lot of these techniques. I do not give a method nor process quite deliberately, because I just wanted to present these techniques and get people playing with the models and so on and the ontologies. And it's very, very customizable. There was a second book that came at the time by the amazing Michel Denedy and Jonathan Fox, called the Privacy Engineers Manifesto. And actually, we discovered that we were both writing these books on privacy engineering at the same time. And then when we finally met and the books were published, we realized we had two very, very complementary books. Mine is technical, they're more management based. Read the two together, and that will give you a very strong basis for privacy engineering. And sometime in 2022, there is a book called Modeling Privacy, and which will go maybe into a little bit more detail and discuss more of the risk analysis stuff, and that will come out in 2022 when I actually finish writing it, as privacy at the moment isn't my main area. So, but I can still keep a hand in that. So I will stop here and hand back to Jules, who will deal with
Thank
this.
you very much, Jan. It was very, very interesting, and we understood we have to ban PII from our vocabulary now.
Yeah.
We have 3 minutes left for Q&A, so that's perfect timing. And following democracy principles, I will ask you the question that had the most vote in the chat. So according to you, what is the level of maturity needed by an enterprise to go into privacy engineering? And to complete the question, Christian wants to know also, for a startup, at what stage should a startup integrate a privacy engineering based process?
Right. Okay. So get away from processes, because for a start, so do everything in a very light manner. You do not need any maturity. Pick up the book or pick up some of the slide sets or whatever, and just start writing models. Sit down, get your engineers to sit down and just ask the question, okay, where's this stuff floating through the system? That's all. You do not need huge processes. If you are developing processes, then you're developing processes, not building a product. So you don't need any high level of maturity. You just need to sit down. Literally, some of the best models we've ever written have been on a single sheet of A4, written in pencil over a coffee table, because the models are there to facilitate a discussion, not as a compliance tool. So yeah, just sit down, take your system, say, okay, who is my data subject? Where's my data flowing? Is it going out to some back ends? And literally, as I said very early on in this, we had an initial template model that consists of device, backend, data subject, and two processes, and that was it. And that was the basis of all our conversations. So there is very, very minimal startup. If you want to get into full processes, that's another thing altogether. And I kind of try to avoid that, because that just complicates the whole software engineering process. So no maturity needed.
Okay, thank you very much. I just ask you the question, but we will not have time to answer here. But maybe if you have 5 minutes to answer in the chat, lots of people ask, how do you test if there is no privacy regression in your systems when you update your system, your apps? And so how would you do like kind of TDD for or BDD or
Oh God.
frame test for privacy?
Yeah,
So
that's extremely difficult, and I have never seen anybody do this in a formal manner. So I haven't really seen this written down. Most of the work that we did was we did a lot of this by hand and just through discussion.
okay.
Admittedly,
Thank,
yeah.
okay, thank you very much. It was very, very interesting. So thank you very much, and don't hesitate to interact with the chat if you have some time for all the questions.